People keep telling me that I should cut my hair because you can't see your code. Well, I don't need to see my code because I am the code. Hey, what's poppin', everyone? So in this video, I'm going to go over the differences between SQL and NoSQL and what is the best database for your data, and also some tips on NoSQL since it is less used than SQL. So let's begin. Now, this is very important to understand because if you ever want to work with data, you need a way to store the data. And SQL and NoSQL can be good to store data depending on your purpose. And you're going to need to know that purpose and why you're storing the data first before you actually store the data. If you're just storing your data just because you have data to store, you're kind of becoming like those people that just like store like everything in their house and then they never use it. And I'm sorry if you do this, but it's kind of a waste. I mean, not saying I don't store some stuff, but I won't use. But I always think that if you store data, you need to have a way to use it, or you need to have a purpose behind why you're using it. So I'm qualified to teach you on these concepts because I have used both SQL and non-SQL databases, and at my job, and I have used them sufficiently enough that I feel like I can understand the differences well enough to tell you about it. So let's really start now. But before we start, make sure to triple click that like button for the YouTube algorithm, as it'll help me help you to understand SQL and NoSQL. So SQL and NoSQL, they are used for different purposes. So you generally don't want to use one of them for all use cases. You want to make sure when you're for your use cases, you have to specify if you want to really understand, is SQL or NoSQL going to be better for this use case? So let me tell you some SQL engines that you might be familiar with. So PostgreSQL, MySQL, MariaDB, Microsoft SQL, Oracle, Aurora, which is Amazon's SQL database. And then some NoSQL databases are DynamoDB, very common AWS database people use. There's MongoDB. It's not AWS, but there's CouchDB, DocumentDB. So DocumentDB is AWS's MongoDB, if you did not know that. And then let me tell you what SQL stands for. I probably should have mentioned this earlier, but SQL stands for Structured Query Language. And NoSQL stands for No Structured Query Language. So there's no structure in the table, and that probably gives you some hints on the differences. So NoSQL data is not modeled in tabular relations. So what does that mean? So it means that you're not going to reference data in one table from another table. So you're not going to look at one table and have references, have a column that references another column in another table. You're not doing that. So that's what it means that it doesn't have tabular relations. So that's what SQL tends to do, which not all SQL does that, but it has a tendency to move towards that direction. So another difference between SQL and NoSQL is consistency. They have different consistency models. So most NoSQL databases offer eventual consistency. And what does that mean? It's a very important concept when you're looking at NoSQL. It means where changes that are propagated to the table and the nodes are going to eventually be propagated. That's where eventual consistency comes in. So for example, if you want to add to a table, it'll take some time for the table to really ingest all that data so that when you get it, it will eventually come out there. It might take a couple seconds or maybe a minute or something like that, depending on the table. And this is contrary to SQL's consistent data structure. So this means that queries will return data immediately after a change to it. So you make a create table or something like that, and you add data to that table, and then you write some SQL code to do that, and then it'll immediately take place. That data will immediately be in the table. It's very consistent. So next thing that's different is, of course, availability. So since NoSQL has a kind of eventual consistency, that was traded off for availability. So NoSQL is much more available. Well, I wouldn't say much more, but it's definitely more available. And from that, it's generally faster and more available than SQL. But SQL is more consistent. So that's where the trade-off is. That's the underlying trade-off between NoSQL and SQL. So another difference between them is, of course, in their scaling. So what do I mean by scaling? I mean how do you make the database bigger if more and more people want to use this database. And by people, I mean like a backend server or serverless kind of architecture that will eventually call this server or the server that the database is running on. So like RDS, for example, if we're using AWS. So the scaling is going to be different between them. So SQL has a tendency to scale vertically. And what do I mean by vertically? I mean you get a bigger individual server that the database is running on. So you for example, you might double the amount of cores, CPU cores, get more RAM and stuff like that. So make it bigger basically. So kind of when I think of vertically, I'm thinking like I'm climbing a tall mountain and you kind of have to vertically climb the mountain, okay? But NoSQL, you want to scale it horizontally. So I'm thinking like a farm. You want to get more servers for your server farm. And how do you make a farm bigger? You don't stack the wheat on top of each other. That's not how you build a farm. You make the farm, you dig it like wider and longer. And yeah, that's how you scale horizontally. So NoSQL will scale horizontally, while SQL will tend to scale vertically. I say tend because in most cases, this is what's going to happen. So to know which one you want to use, whether it be SQL or NoSQL, you need to know ACID. And I'm not talking the chemical acid, even though my major was physics in college. I'm talking about ACID in terms of databases. And if you do not know what that means, I'm talking about atomic, consistent, isolated, and durable. So atomic is where each transaction is all or nothing. So you kind of think of like an atom. An atom is all or nothing. You either have the atom or you don't have the atom. So like in a transaction, you either have the transaction work and data is added to the table, or it is not added to the table. So ACID, I don't know if I mentioned this, but ACID relates to SQL databases. Well, we'll get to base, which relates to the NoSQL databases. So atomic was the A. Consistent, I already mentioned before, but data must be valid for all rules. So that's the C. Isolated is the I. So kind of isolated means that transactions don't interact with each other. So for example, if you have two different queries going to the database at the same time, one, they're not going to interact with each other. So they don't meet, they don't touch. So that's what isolated. And then the last one for ACID is durable. So durable means transactions are permanent. So like for over a certain long period of time, like many years, the same one transaction will have the same effect that it had like for many years before. So it's durable. All right, so when we're talking about NoSQL, you need to make sure you drop the base. So base, B-A-S-E, if you didn't know how to spell base, but I'm not talking about the music base here. I'm talking about, or the chemical base either. I'm talking about base as in basic availability, soft state, and then eventual consistency. So I'll get to what those mean. So basic availability means that the data will be available eventually, but might be in a changing state at any point in time. So this is referencing the availability before. So like once you make a query into the table, like you put something in the table, it'll be there eventually. We don't know how long it'll take, but it will be there eventually. So that's the basic availability, the BA. I don't want to say what BA stands for. But then there's the S, which is soft state, and you can say that's two S's, and that's true, it is two S's, so maybe I spelled base wrong. But soft state would means that the state can be changing at any time. At any point in time, it can be changing. So that's soft state. And then there's eventual consistency, which I said many times. Data will propagate to everywhere in the database eventually. So that's the base. And base, of course, is for NoSQL. And then ACID is, of course, for SQL. So my final words on that is, if data needs to be ACID compliant, use SQL. While if you are uncertain about your data and you don't care about what data will be eventually consistent or not, you're going to use NoSQL. Because when you use NoSQL, you don't define all your columns at the beginning like you do in SQL. Like in SQL, you define all your columns, and then you just go off those columns. While in NoSQL, you kind of can change them as you go. You can have some inputs to the table have some columns differently, and then some other ones have different columns. But all of them, of course, are going to be needing partition keys. And choosing the partition key is very important for a table in NoSQL, because depending on, it could make the table slower or not if you choose like a key that is very common. And I'll go into an example of that. So I'm going to reference here the AWS documentation because AWS DynamoDB is probably one of the most popular NoSQL databases, and I am more familiar with AWS personally. So they store data in partition. So this is where the partition's keys come behind, or they come along. So partition is kind of just backed by solid state drives. That's what's SSD. So that's how it's stored behind the scenes, but they won't say that. But when you create a table, you kind of need a partition key. And DynamoDB will allocate sufficient partitions to the table so that it can handle your provision throughput requirements. So kind of an important tip when you want to create a good partition key is you kind of want to make it unique. So for example, like you don't want to make it someone's birth date because two people will have the same birth date, right? Like might have the same birthday as you, November 11th. But so that could have like the same row in the table, for example. But you might want to combine it like with someone's name. Though that is still not unique because you can have the same name as me and have the same birth date. So it's kind of, you want to make it as unique as possible so it does not produce a hotkey. So that is that. And that is important because DynamoDB allocates additional partitions to a table in the following situations. So these are key situations that you need to understand if you really want to understand like performance with DynamoDB. So if you increase the table's provision throughput settings beyond what the existing partitions can support, or if an existing partition fills to capacity and more storage is required. So I'll link this in the description so you can read more about it if you would like. This is dark mode, by the way. Woo! Anyways, that is the end of this video. I hope you liked it, and it was somewhat informative. I tried to be, at least a little bit. But make sure to hit that like button and subscribe, and I'll make more videos. Talk to you later. Peace.